Thank you, and it's a great honor to be here this morning. Let me start. So Nokia and the future of the internet. What an extravagant title. We do not make mobile phones, right? But what we do have is a wide portfolio of network infrastructure. So IP routing, optical networking, fixed broadband access. With the acquisition of Infinera, we also have a leading SLTE submarine cable landing station portfolio. And I'm not sure if you were reading the news last night, we also received a generous investment into Nokia from a company called NVIDIA. So last night it was announced that NVIDIA is now an investor in Nokia. They made a $1 billion USD investment, and we're going to be working with them on AI RAN in the mobile infrastructure space. We're going to be working with them on optical networking. We're going to be working with them on data center fabric. So I think it gives you a sense, why is Nokia talking about the future of the internet? So at Nokia, we like to say that we are pioneering in networks that sense, think, and act. So networks that sense. They can sense that there's something happening in the network. There might be fiber sensing. It might be other types of awareness in terms of traffic and patterns. Also, think, okay, what should we do about that? What type of reaction should we have? What type of learning can we gain from that? And then ultimately act. Autonomy, right? TM forum type of autonomous networks. And so we think that we have the broad portfolio in terms of mobile infrastructure, network infrastructure, cloud, and software to really pioneer how networks sense, think, and act. And what I want to do is talk a little bit about the mega trends, and I'm obviously going to focus on AI. But let me first start with AR and VR. I think we've seen a lot of consumer products, right? And we've had some recent announcements from Samsung Galaxy. We've had a new Meta version of the glasses with now a neuro wristband, which is a new concept. And obviously Apple and their Vision Pro also announcing new products. And that's just in the consumer space. I think in the augmented reality space, for enterprises, we're seeing a lot of use cases. This is really fueling a different traffic pattern and a lot of different types of connectivity. And then we have cloud. We had private clouds, then we had public clouds, then we had multi-clouds, now we have neo clouds. We have a lot of clouds. But these clouds need to be connected, and that's where we come in. I think artificial intelligence is bringing a different type of cloud paradigm in terms of where you put training, where you put inferencing, but all of these things need to be connected. And that's what Nokia is. It's a connectivity company, right? We specialize in this type of connecting the cloud to the end user. Now that can be with fiber. We have a leading portfolio in fiber to the home, fiber to the premise, fiber for everything. We're also a leader in 5G. And also we're seeing increasingly some interactions with not just the internet, but also the outer net. What are we doing with non-traditional, non-terrestrial type of connectivity? This is also part of the mega trends that we're seeing. And so what am I really talking about here? I'm talking about connectivity, right? Connectivity between data centers, data center interconnect. The primary way of doing that is with optical networking. And again, after the acquisition of Infinera, Nokia is a leader in optical networking, right? We're talking about now within the data center, what's the type of fabric that we need? Is it the InfiniBand? Is it the Ultra Ethernet consortium? What type of scaling up and scaling out can we do in terms of connectivity? And then once we understand within the data center, how are we moving to the edge? In fact, where is the edge? We've been talking about the edge for a while, and now we're actually moving on to premise, and then ultimately to the end user. But when you look across that continuum, what we're actually talking about is connectivity. And again, this is what Nokia does in terms of now connecting data centers and increasingly connecting AI factories. So I want to talk about AI, because AI really is the mega trend. It's fueling most of the traffic. It's fueling most of the connectivity between these data centers. And maybe if I can put it into four dimensions, right? So we have lots of data centers now across Europe. tens of thousands of data centers, right, in every country. And I think what these data centers need, first of all, is scale, right? The type of workloads, the type of traffic, the traffic patterns that are happening with AI is very different. People talk about elephant flows and mouse flows. It's a very strange dimension, but different types of traffic patterns. We also obviously need quality, right? The networks need to be more resilient than ever. We need to have a lower latency. This is really, really important when we start to think about inferencing. And security. This all has to be underpinned by security. At the same time, for the operators, of course, we need automation. You need to be able to abstract this data, work with the data, manage the data. So automation is really, really important. And then lastly, collaboration. We can't do this alone. The service providers can't do this alone. It really is an ecosystem. You see many players now collaborating and working together. NVIDIA investing in Nokia, OpenAI working with other players. So it really is an ecosystem of partners that need to make this happen. And I'm going to talk about these kind of 4 things as the tenets for what I'm seeing. First thing, scale. So we see AI traffic actually reaching by 2033, 1,000 exabytes a month in terms of traffic. That's huge. That's a CAGR of 24%. And what it really represents from where we are today, maybe 1/10, is going to be 1/3 of traffic by 2033. Don't take John's word for it. This is coming from Bell Labs. So I think Bell Labs are a pretty good institution. This is what they're predicting by 2033. And what does it mean? Well, obviously it means generative AI, right, coming from consumers. But also it's agentic AI. When you actually start to think about what is AI, it's not just generative AI that we're getting prompts and texts and large language models. It's also now agentic AI, where machines are starting to talk to machines, and we're starting to get this autonomy. So this is what we see in terms of the traffic. Of course, regular traffic is still growing, but we think AI traffic will be 1/3 or more by 2033. So scale, when we start to think about this scale, that really impacts our networks. And then people talk about AI like it's this mysterious factory, right, that's owned by hyperscalers. And today it is, right? There's a lot of training that's going on in these AI factories. We're now having in Europe people starting to think about AI gigafactories, where you might have 100,000 GPUs operating in a gigafactory, doing lots of things for research and education, doing other types of commercial and government type of applications. And this is training, right? These are the large language models that are being trained within these central locations. But what's going to happen next is this training is going to turn to inferencing. We're going to have now actually things moving closer to the edge, workloads shifting to closer to the users, and they're doing that for a number of reasons. So what we see actually in the next couple of years is AI moving from training to inferencing. And what does that really mean? Well, what it means is, of course, we're going to have moving from large language models to smaller language models to actually even tiny language models that reside on a device or reside much closer to the user. Why are we doing this? Because we need lower latency. Because we won't need the processing power of the large language models that's been trained. We now need to interact at an enterprise level, at a user level, and we may have some security concerns, right, and capacity concerns and networking concerns. So we want to move the consumption of AI closer to the edge and closer to the end user. When we do that, the other dimension that we really need to think about is security, right? These connections have to be highly secure. At layer 0, we have fiber sensing. That's not a new concept for the submarine cables, this OTDR type of sensing, if there's a problem with the fiber. But that's something that we're starting to see in terrestrial applications as well. What type of fiber cuts, tampering, is there something happening with the fiber infrastructure? Obviously, we have the DDoS protection. Nokia has a DDoS protection. We're looking at now layer 1, 2, and 3 in terms of can we stop attacks? What types of things are happening with the network? Can we train our own network to recognize that there's a problem, again, to sense and to think and to act? And we're actually now moving to a quantum safe type of networking. So what Nokia and other industry players are working on is post-quantum cryptography and also quantum key distribution. How can we protect ourselves from Q-Day? People have different opinions on when Q-Day is coming. Is it in the next 3 or 5 years? Is it 10 years away? But it is coming. I think there will be a point in time in the, let's say, near to medium future where a quantum computer can crack the RSA algorithm. So now we have all this very sensitive information, all these trained language models going across the network between AI factories to the edge cloud, to the premise, ultimately to the device. We need to make sure that we have this quantum safe networking. And this is something that we're also working on. And then moving a little bit to automation. When we've had some different surveys done here, and I think the number one concern of the average telco is automation. Understanding all of this complexity, how do I now manage my data? Right? We need event-driven automation. We need things that can be done in a more natural language. We need to have this autonomy, coming back to the sense, think, and act. We basically want data centers to become more autonomous, right? Less user input, better prepare for changes. Things are going to be spun up and spun down much more quickly in a data center. And so, of course, improving network automation is probably the number one challenge for the major organizations operating data centers. Power consumption, of course, is number two, which is why when we move away from centralized AI factories to inferencing, to small language models, there's also a benefit that there might be a more abundance of power, right? So you have latency, you have power benefits, security benefits, and this is all helping the way that we see the networks evolving over the next 2 years. The thing with artificial intelligence is we unfortunately still have stupid humans. I did see some laughs, so I know it's working, right? Artificial intelligence and some stupid humans. And what we've seen actually in some surveys that we've done or been done by the Uptime Institute is 39% of these outages are caused by humans. I'm sure it's not the cleaner in like cleaning the floor of the data center. It's probably someone putting in the wrong piece of code or doing an upgrade. But the point is, we have to also protect ourselves, not just on the networking, but also on the operations. And we have something we call event-driven automation, which allows us to do things in natural language. It allows us to test things in a digital twin before they're deployed on the network. So I think as the internet or as AI continues to evolve, we also need to think about the operational aspects of automation as well. And we can't do this alone. So in terms of collaboration, we have to have open standards. We have to have open networks. We have to have multi-vendor networks. We're operating at the optical layer. We're operating at the IP layer. They can be from different suppliers. We're operating between data centers. We're operating within the data center. I mean, to give you an example, we're deploying our hardware in a Sonic environment with Microsoft, right? We have a 5-year agreement with Microsoft to put our data center products into a Sonic environment with Microsoft. On the flip side, with Supermicro, we're supplying our SR Linux software that's running on Supermicro hardware. These things need to be open. N-Scale, I'm sure many of you have heard of N-Scale. We're working with them on the vertical stack integration. They're working with AMD, they're working with NVIDIA, they're working with the compute vendors, and we're kind of certifying all of these types of configurations. And actually, we signed a strategic partnership with N-Scale. They're one of the very early neo-clouds that are offering GPU as a service. But behind them, Nokia is working with them on the data center fabric. Actually, it was publicly announced, so I can tell you, Nokia invested in N-Scale. We're actually an investor in N-Scale. NVIDIA is now an investor in Nokia. So you can see the ecosystem that's required, the collaboration that's happening. Of course, we have the wonderful traditional customers such as DKIX internet exchanges, service providers. We continue to work with them. But to do this effectively, I really believe that we need a co-creation and a set of collaboration. That is also true, of course, in the submarine landing stations, right? We have submarine cables that are normally either coming from directly from the hyperscalers or they're coming from consortium players. So we need the telcos to continue to collaborate because they're basically providing the connectivity, between continents. And what is this connectivity? What is it really? It's data center to data center in 80 to 90% of the time. And we're seeing that the capacity is insatiable. We're seeing 72% now of these cables are facing exhaustion. So we're going to see more and more cables. Lisbon is a great strategic geographic location to have some of these submarine landing stations, and then to connect to the terrestrial network to be a gateway into Europe. So we need the industry to continue to collaborate in this and create these expressways across continents. And then another example of co-creation or collaboration is MOFN, right? Managed Optical Fiber Networks. This is where it's kind of it's not a new concept, but it's where a telco provider is basically offering a managed service to the hyperscalers. They're saying, hey, you can use my infrastructure. Let me provide a managed service to give you the best SLA, and let's have this as a kind of a managed capacity across the network. So this is another great example of where hyperscalers, service providers, connectivity companies can collaborate together. We don't want, I think it would be bad if we just say hyperscalers build your own network and ignore people like Mayo and others that have great critical infrastructure, great critical assets, and can use that fiber infrastructure as an example, the edge clouds that they already have. We need to work together to collaborate on these things. So I started with these mega trends. I would say yes, virtual reality, augmented reality is coming, right? We've seen the early signs of it with the glasses. We talked about the metaverse a few years ago. We're not talking about that so much now, but that was an early sign of, I think, of what's to come in augmented reality for enterprises. Cloud. Okay, everything's being put in the cloud, from enterprise workloads to AI clusters. But these things need to be connected. And again, that's what Nokia does in terms of scale, quality, automation, and collaboration. So I think hopefully now you better understand, what is Nokia doing in this AI factories and in the future of networking. And we'd love to talk some more with you at our booth. We've got some quantum demonstrations that our friend Roland is going to speak about tomorrow. We've got some of the automation things we've talked about for data center fabrics. And we look forward to having some conversations with you over the next couple of days. So thank you very much for your time.